Alright, so today I thought I'd start a little video series on how to build yourself an economical, fun robot chassis. I was going to start selling some, but then realized there's just no way that I can practically compete. I am going to have one on the website, one of these chassis here, which is going to be $15 or something like that. But basically, you know, building your own is well, it's rewarding, it's fun, and it's remarkably cheap. So I thought I would just start a series. And I'm also going to show you how to build your own and then drive it with 3 different types of motors. I have a servo motor, which is modified to continuously rotate. One of these economical DC motors, this can be scaled up to, well, actually all the way up to an electric car like the one I drive around town. And a stepper motor. Okay, and let's start off with the servo motor. The servo is probably the easiest one to control and easiest one to hook up, and I'll recommend it as the first one you start off with. It only takes one wire from your processor, okay, one I/O. The other 2 are going to be the voltage that powers the motor, and it's most of the software has systems already built in to control them, or you can just roll your own just by pulsing it at a rate between 1 and 2 milliseconds, and we'll talk about that when we actually get it running. The DC motor, I can't run it directly off a processor. And of course, if I take this and hook it to a battery, it's just a kid's toy motor, really, this little DC motor in here. If I hook it up to the positive sides on this side and the negatives on this side, it's going to rotate one direction. And then if I just flip my battery, it's going to rotate the other direction. But doing that electronically is actually a bit difficult. You need something called an H-bridge. That gets you into something like this, which is an H-bridge. It's a dual H-bridge. It will run 2 DC motors, and it will allow you to electronically switch the direction and, by pulsing it, set the speed. The downside of using one of these is it does start tying up more and more I/O pins. So more and more your processor goes into it, and you have to work at making it you know, a lot more coding. Excuse me. Stepper motors. Stepper motors are wickedly cool. Smaller stepper motors tend not to be very torquey, so they don't have a lot of power, but their control is impressive. I can step it off just 1 or 2 degrees in every direction, so I can know exactly where it is. It too needs a different type of controller. I can't, with most microprocessors, send power down this line sufficient to actually run this motor. So I need some sort of an intermediate board that's going to be able to handle the higher current and be able to drive the motor from the processor. Again, a little more difficult to program, lots of fun to play with, but does use up more I/O generally. If there are devices available that allow you to control a stepper motor, which is 2 wires, which is going to be 1 for the direction, 1 for speed. But most of the time, if you're running it straight from the processor, you're going to be talking about, generally talking about 4 wires to control it. So you got 8 I/O just running 2 different motors. Okay, with that in mind, let's get started, and let me show you, I'll move these things aside, a very simple robot that you can build remarkably cheap. Okay? So this is just a wooden platform. I've got 2 servo motors on the bottom, a wooden ball for the tail, and it's just made out of hobby plywood. Okay? To buy enough stuff to get one of these, actually it's hard to get enough stuff to buy just one or build one. Usually you have to buy, you know, a $3 bag of parts, which will, you know, give you more than enough to build several of them. For example, you know, this package here from Hobby Lobby contains 6 pieces of pre-cut laser cut plywood which is what I use without any modification to make this chassis. So one bag of these makes 6 of them. This bag here from Hobby Lobby as well contains all the tail balls. I can make 9 of them with one bag, and these were $4. It was the most expensive part. The blocks that you see that are glued down to hold the servos, you have all the choices there. You can buy bags like this for about $3. I actually did this one by going to Home Depot and just buying a length of it so that I can just cut it myself nice and square. And if you're going to do that, you need something like this to cut it square. And you can see these are really affordable. This is from Home Depot. It's called a miter box. Comes with the saw, and you lay the board inside of there, and there's plastic guides that hold the saw blade in place. And that way you always end up with either a nice 45-degree angle or a 90-degree angle, and you don't have to worry about it. So, that being said, let's take a look at this, and I'll probably break this into another video here. One of the fun things about building a robot like this, I already had the screws out, is you can make it any way you want. For example, these wheels are actually from a package like this, okay, again from Hobby Lobby, and that was actually, in this case there's only 4 in a package. I think it was $3, $2.99. And I have a separate video to show you how to find the center of a circle. That's probably the hardest part about this, is actually getting a hole drilled in the center so everything lines up, but that's actually easy to do. And if you know this technique, and if you know how to find the center of a wheel, you can make wheels. You don't even have to spend the $3 to get 4 of these. This one is just made out of salsa lid jar, okay, and salsa jar lid, and you can see it fits on there just fine, okay. And you can have this made out of jars. In fact, if you have that miter box I was telling you about, you don't even hardly have to spend any money at all. This chassis, I've taken the servo motors off, is made out of 2 of these paint stirrer sticks, okay, which I got for free at Home Depot. I simply laid it in my miter box, cut them off at 7 inches, okay, 2 of the thicker ones like this, the bigger ones for the 5-gallon buckets, and laid them together and glued it together. Okay, so now I had my plank, and then these side pieces here, okay, are nothing more than the 1-gallon size paint stirrers, and I simply laid those on my miter box and cut them and glued it on. This one even has little mounts up here that I made so I can put an adjustable sensor. And again, that was nothing more than laying this stick on my miter box and cutting a 45-degree angle. Okay, so this one has a fancy wheel, okay, which I got at Home Depot. All right, like I said though, the balls actually work really, really well. And this, if you use the wood ball, would probably cost you, well, the cost of the wood ball, which would be maybe 50 cents or something. Throw on a tail wheel like this, and you're up to maybe $1.50. This one, you can build probably, let's see, I had to buy 2 packages of those to get 8 wheels, so 4 of them would cost me, I don't know, something like $8 or $10, and I could have 4 of these chassis. And that also allows me to do custom stuff. I could easily make this so that the wheels were mounted like this, and in fact it would look somewhat upside down, and then I could just glue another deck right on top of this, right? So I can have layers of decks, which gives me lots of room for hiding batteries and electronics. So I really think this is a great way to go to make yourself a robot that's affordable and fun, and you won't worry about it. Okay, so that being said, I'm going to end this one Next video will be actually putting one together real quick, and then I have a video about finding the center of a wheel, and we'll move on to other types of motors, and we'll play with them all and get them all working. So I will see you soon.